Dear students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now we are solving questions from the topic sigma notation. We have learned the meaning of sigma notation. Why is it used? It is used as a shorthand notation for representing the terms of a series, which is very needed and is very helpful when we are having many terms of a series. When we are having, say, 100 or 1000 or 2000 or 10,000 terms of a series, then it is not possible for writing each and every term individually. We cannot write the individual terms of that series. Therefore, we should be having a way of writing all the terms, expressing all the terms, but in a concise manner. And that is when we require this sigma notation. If a series consists of 5 terms, we will be writing those 5 terms. We actually do not need a sigma notation to represent that series consisting only 5 terms. But when a series consists of many terms, then it becomes difficult for us to write all the terms individually. Rather, we prefer to go for a shorthand notation, and that shorthand notation is the sigma notation. Okay? And today's topic is sigma notation and the geometric series or geometric progression. Okay? How do we express a geometric series or a geometric progression using a sigma notation? Let us know. So the first question of this session is evaluate sigma. The variable is k. K is running from 1 to 25. The starting value of k is 1 and the ending value of k is 25. And the expression given is 6 times negative 2 to the power of k. We will be substituting different values of k to get the different terms of this series. And how many terms are there? 25 terms. Because the k value is starting with 1, so the first term will be having a k value of 1. Therefore, the 25th term, the k equal to 25 will be representing the 25th term. Okay? So let's start with our answer. We have to evaluate this series. But we do not know what type of a series is this. Yes, of course, our today's topic is sigma notation and geometric series, but if it is an examination question, they will not be saying this is from this topic. They will be just giving you this question, and it is you who will be deciding what type of a series is this. You have to first know what type of a series is this, and only after that can you apply the relevant formula. Okay, so for that, for the identification of the series, we have to get few terms of the series. Let us start with the very first term, when k equal to 1. So when k is equal to 1, negative 2 to the power of 1 is negative 2. Times 6 is negative 12. Therefore, the first term is negative 12. Second term, k is equal to 2. Negative 2 whole square is positive 4. Times 6 is 24. Third term, negative 2 to the power of 3 is negative 8 times 6 is negative 48. Fourth term, negative 2 to the power of 4, that is positive 16. 16 times 6 is 96. and it is continuing till 25th term. Up to 25th term. Okay. So now we see that there is a common ratio existing between the consecutive terms, and that common ratio is equal to negative 2, because negative 12 times negative 2 is positive 24, positive 24 times negative 2 is negative 48, negative 48 times negative 2 is equal to positive 96. So the common ratio is negative 2 and U1 is of course equal to negative 12, and n is equal to 25 because there are 25 terms of this series. So we can apply the formula for the summation of the first n terms of a geometric series, where the first term is U1 and the common ratio is R. I am taking this formula because R is less than 1. I am taking this formula 1 minus R to the power of n over 1 minus R. Okay. So n is equal to 25, therefore it will be S25 is equal to U1 is equal to negative 12, and 1 minus negative 2 to the power of 25 over 1 minus minus 2. So this is 1 minus minus 2 is 1 plus 2, which is 3. So let me write over here negative 12, 1 minus minus 2 to the power of 25 over 3, and it can become 4. So it is practically negative 4 and 1 minus minus 2 to the power of 25. So what is this number equal? It will be a negative number because negative 2 to the power of 25 will be a negative number, times by minus 1 will be a positive number, and we are having this negative sign, leading negative sign. So I do not know the value, but definitely it will be a negative number. Let us use the calculator. Okay. So it is negative 4. It is negative 4 times 1 minus negative 2 to the power of 25. Okay. So yes, negative 4 times 1 minus minus 2 to the power of 25. What is this equal to? It is negative 134,217,732. Negative 134,217,732. Okay. So let me write the answer. Negative 134. Let me again see the thing. Negative 134,217,732. 217,732. Okay. So this is our answer. Negative 134,217,732. Okay, fine. So this is our answer. We may write it over here. Negative 134,217,732. 1732. This is our answer. So let us move on to the next step. Just a moment. I have written the answer over there. So I erase that equal to sign. And now we move on to the next question. Okay. Find n. This is the ending value of k, given that the summation of this series up to n terms is equal to 177146. Okay. First thing that we have to find out is what type of a series is this. Okay. So let's start with our answer. For that, we have to get the first few terms. We start with k equal to 1. When k is equal to 1, 1 minus 1 is 0, 3 to the power of 0 is 1, 2 times 1 is 2. So the first term is 2. Second term, k is equal to 2, 2 minus 1 is 1. So 3 to the power of 1 is 3 times 2 is 6. Third term, k equal to 3. 3 minus 1 is 2. 3 square is 9. 9 times 2 is 18. Fourth term, k equal to 4. 4 minus 1 is 3. 3 cubed is 27 times 2 is equal to 54. And it is continuing up to n terms. Okay. N terms. So now we see there is indeed a common ratio between the terms and it is equal to 3. So r is equal to 3 and u1 is equal to 2. And we have to find the value of n. So again we will be using the geometric series formula. So it is Sn is equal to u1. u1 is 2 and it will be, since r is more than 1, I am taking this formula 3 to the power of n minus 1 over 3 minus 1. This should be equal to the given number 177146. And 3 minus 1 is equal to 2. So these two will be getting cancelled. Okay. And we get 3 to the power of n is equal to 177146 plus 1. So it is 177147. Okay. And then we may take the log of both the sides to the base 3. So it is in log 3 to the base 3, which will be equal to 1, is equal to log 177,147 to the base 3. What is this value? Let's check. Log. Okay, log to the base 3 and it is 177,147. Let's see. It is 11. So this is equal to 11. Or since this part is equal to 1, therefore we may write n is equal to 11. Okay. So this is our answer. N is equal to 11. Now, the next question of this session. Okay. So the question says find x. This is a similar question, but instead of n, now we are having this infinity, indicating that this is an infinite sequence or infinite series. And x is a variable present in the expression of the term. It is not the final value of a, it is present in the expression of the terms. Okay, that is the only difference of this question with the previous one. And as I have done with the previous two questions, first of all, you have to decide, you have to identify the series. What type of a series is this? Okay, so let's start with our answer. So we will be getting first few terms. K's starting value is 1. 1 minus 1, the power becomes 1 minus 1, that is 0. 3x over 2 to the power of 0 is equal to 1. Next, it is plus, extremely sorry, most probably I have made this mistake. I apologize because this is the sigma notation. You have to write plus signs instead of commas. Okay, because it is a series. The terms are definitely these, but because it is a series, you have to write the plus signs. Okay, I have written the commas by mistake. And what about the first one? Yeah, I have made the same mistake over there as well. So it is minus 12 plus, this is 24 plus this plus 96, and then it will be plus and so on. Okay, so you have to give this plus signs because of this sigma notation. Okay, so coming back to our question, the first term is 1. For the second term, k should be equal to 2. So the power is 2 minus 1, which is 1. Therefore, the second term becomes 3x over 2 to the power of 1, that is equal to 3x over 2. For the third term, it is k equal to 3. And 3 minus 1 is 2. So the term becomes 3x over 2 whole square. Okay, and it continues up to infinity. Okay, so now we are seeing there exists a common ratio that is equal to 3x over 2. And the first term u1 is equal to 1. Okay, so it is a case of an infinite geometric series, and since it is having a value, therefore we may say that this is a case of a convergent infinite geometric series. Now, I have seen two types of answers. So I am showing you both the methods. Okay, so method 1. There are students who try this method. They say that since it is a case of a convergent infinite geometric series, therefore r value, that is 3x over 2 in this case, should be less than 1 but should be greater than negative 1. Okay, yes, that is definitely true. Therefore, they try to get the value of x by multiplying all the three parts by 2 over 3. So, what do we get? 2 over 3 times negative 1 should be less than 3 over 2 times 2 over 3 should be less than 1 times 2 over 3. And these two will be getting cancelled, and we will be having, taking this to this part, we will be having negative 2 over 3 is less than x is less than positive 2 over 3. This is indeed true. But the question does not say that find the possible range of values for x. This is giving you the range of values that x may have. But we do not know what is the value of x for which this series will be having a value of 4. So, I would ask you not to go for this method, because this method is giving you a range of values and the question asks you to give the specific value of x which will be making the series value equal to 4. Okay, so now we come to the method number 2. So, it is the method number 2 where we will be using the infinite geometric series formula. Okay, so it is, let me write the formula, S infinity equal to U1 over 1 minus R. Okay. So, S infinity equal to U1 is equal to 1 and 1 minus R is equal to 3x over 2. This should be equal to 4. Okay. So, 1 over 2 minus 3x over 2 is equal to 4. Or 2 over 2 minus 3x is equal to 4. This gives us 8 minus 12x is equal to 2. Or 12x is equal to 6, implying x is equal to half. And you see, half is indeed greater than negative 2 over 3 and is less than 2 over 3. 2 over 3 is 0.6666, that means 0.6 recurring, and half is 0.5. So, it is definitely less than 2 over 3 and is greater than negative 2 over 3. This method is giving you the exact value of x which will be giving the series value as 4. So, this should be your answer, not this one. Okay. So, we write the x value, x is equal to half or 0.5. This is our answer. Okay. So, students, this brings us to the end of our session, today's session. We will be meeting very soon in our next video session. Thank you for watching this video till the end. Please give this video a like in case you found it useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos which may be helping you in your math classes. And do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. Okay? So, bye for now.